Hello, today I'm going to be discussing random terrain generation or pseudo-random terrain generation. My name is George Hayes, and this is the continuation of the RPG tutorials, and I guess this can actually be used for a lot more than RPG. For anything you pretty much need terrain generation. We're going to be discussing two methods. Today there are multiple more or many more methods other than the two that I'm going to be discussing, but these two are fairly simple and give you an idea how things work to start with. And this first one, what we're looking at right now, is actually a terrain being generated that's already generated, and the water or blue is the lower ends, and when you get up to white, it's the higher peaks as far as on the hills. Now, the simple way this one was made is we start off with a 2 by 2 square, and a 2 by 2 square is then tessellated or broken up into a 4 by 4, and then 8 by 8 and 16, 16, 32, 32, and 64 until we get up to 512 by 512, which takes 8 iterations as far as running through that. And each time I'll go ahead and show you how that works here. All right. Basically, here's your 2 by 2 square to start with, and then each of these are broken up. Now, what you've done is you initially assigned a height to each of these four squares, and they don't have to be the same thing. They can be the same thing. You know, it's up to you. Depends on what you're trying to match up with other terrain that's around it or not. And so what you do is once you've got your original height set in here, you then sit there and calculate for your 4 by 4 as far as in here where you're going to go to. Now you want to set the value of this one here. Well, you're going to take the original height value of this plus the original height value of this, divide it by 2. And then whatever your change amount is, let's say your original amount was 4, you're going to sit there and use 1/2 of it. So you go to 2, obviously, in this case, and you're going to either plus or minus that randomly based on whatever your random generator is. And you could say if it's greater than 50%, you add, and if it's less than 50%, you subtract. Well, this one here is this one here plus this one divided by 2, and same method, and then this one here is this way. All right, and that's how you do it. And then on the next iteration run, well, you're going to do the smaller squares that are as far as in here, and you're going to continue to repeat that until you get the size of map you're looking for. Okay, so basically this here is where I initialize it. So if you want to manipulate the seed and see the changes on it, you can come in here to on init and change these, and simple as changing one number or 10, making a whole new set of numbers. You can sit there and do it. So we'll go ahead and close that one, and you've already seen it, so we'll go ahead and rebuild, and we have a slightly different terrain. And if we close it again and take off a few more of these, or just change the number entirely, get another terrain. All right, and so it allows you a very large number of terrain based on it, and it's using a pseudo-random number generator in here. And let's see if I can pull that up real quick. It's not the greatest one in the world, but it works for what we're doing here. And let's see, pseudo-random generator. Okay, so basically it takes in a seed, and I have mine where it also pulls in an XY coordinate and uses it to add to it, and it goes through and makes some manipulation changes in here as far as for forcing it to change around. And basically, so what you're doing is you're taking the mod of this value here from this here each time, and then dumping it back and out, and then out gets fed back into this. Well, when you sit there and you do that, you also have this running as far as down here, and when the CC up here happens to actually match it, right, that percent 97, A becomes 0, and it causes the thing to switch it back and change. So you get sort of more of a mixed up random event of it. You get areas that'll actually repeat over and stuff like that. So it's not some linear going right down the same thing, because you'll find a number of them that will just be very similar to take these out, and it'll just go through and it'll repeat and be the exact same repetitive system each time. So this here breaks up the repetitiveness. And granted, it's a long amount of repetitive ways to go as far as to repeat when you have a number this large in here. But you could actually do this with a 64-bit, unsigned long, and have a much greater area as far as numbers and stuff like that. But like I said, this is just for being used as far as in this, and it's effective to what we need right now. Okay. Anyway, so we'll jump back over to the train chunk generator, as all this is. And right now we're just creating a 512 by 512 area. We start off with setting the first areas to 4. We could set half of them to 1 or whatever values we want. Rebuild and run it, and it'll change the train slightly. And we'll take a look and see how much it actually changed it by rebuilding again. And as you can see, this area here is not as low as it was in the past on this. And so that does as far as on that part. Now, as far as on where I was telling you, it adds the different areas together. Here we sit there and look as far as for uh, what A is and so forth, and we set up as far as for doing our change into here as far as adding the areas, and then sit there and adding whether or not it was greater than or less than 50%, and then we add the change to it. Now, change is up here as 4, and then we take 1/2 of that, and it, as far as on the iteration, is what most systems usually do. You'll see people tell you to do this, and you'll have this out of it, and we'll get a little bit of a different. Oops, I don't think it. Sorry, yeah, I didn't comment it out all the way. Rebuild. Okay, so it's not really in use, and as you see, it's not as detailed and doesn't throw in as much dynamics as far as into it. Now, if we go back into here and we want more height variation and so forth, we put the end back in and kind of smooth out the terrain, even though it looks more rough as far as on the map. We get this, all right, instead. So that was one additional change I made as far as on it. And then as far as I also decided to flip the map upside down each time. And granted, I could also flip left to right or halfway across, move the map, and so forth. And it'll actually improve some of the way the terrain's made. Now, that way it isn't so linear across it, or it could even deprecate the change the map as far as to where shifts partially as far as an angle, you know, like one side shifts down, slightly, moving as an angle. And the further you go across, the further down it shifts, and that way, it doesn't look like it's such a linear thing. Because if you look in this map, there is imperfections as far as, in my opinion, you see it looks very linear, built on lines, and that's because of the way the map is generated. See, there's this line going down the middle and here, and that's the way these squares line up. And so if you can break up those lines by actually manipulating the map and moving it around, you can actually make a better looking map. So that's one system, all right, and you can go ahead and play around with it and make your own changes and stuff to it. But I wanted you to see the basics of it and how it works as far as in here. And uh, there is, if you look at this section here, you'll see where it says tessellate equals a rand, and then you have a very similar line lined out. Well, the similar line is an actual more realistic random generator. All right, that is based off of timing on how your system runs as far as with all the other processes going on. And so it modifies the seed and also dumps in as far as the change as far as looking for the amount of time as far as the rand as far as in here. So we pull back as far as time and add as far as this increment. And see, the reason we add this increment into it is because sometimes this process gets back so fast that you actually end up with the same time being said to all these, and so therefore it doesn't actually make any change. by adding this 97 increment into it, right? It actually forces a change as far as in there, and it's kind of still linear, but it's more random than what we have as far as on some of the other stuff. So if we look here, what we get is maps like this, and it can get vary greatly every single time without having to rebuild it. But the problem with having a true random generated map like this is if you wanted to play the same thing, continue on the game that you were playing earlier, you can't do it. But with a pseudo random generator like we were using the first time, you can do just that. You can sit there and just play, put in the same seed and continue playing. And that's the difference. So we'll go back and put the pseudo random back in here. Alright, and as you can see, we're back to the same map. And we'll hit return again. Don't even have to rebuild. It's just going to be the same. Alright, and it only changes when we change the seed number. Now we can actually have that seed fed in. You know, I'm sure if you're at this level of programming, you can figure that out by now. As far as on it, you can take user input and feed into there and actually change it and manipulate it that way. Or you could sit there and actually use another random number generator and feed into there if you want to also. And that way you get the same effect as far as from the first one. But so here we are as far as on it. So that's one way as far as showing you as far as how to create terrain on there. And I'll go ahead and jump over and close this up, and I'll jump into the next one because uh, the majority of this is actually just I'll run it basically down through it real quick. All right, up here is just variables as far as some changing. There's some variables you can manipulate down in this area, such as this variable here, to make the map changes a little better, less. You know, play around with it, see how it does. There's an area here where we're just basically flipping the map upside down. This is just copying the map from uh, the B vector back into the A and clearing off the B and so forth like that, and resizing and all that stuff. And then here we're actually, after the entire thing is done manipulated, we're sitting there going through and getting the highest value and the lowest value off the map. Then we're adjusting the map accordingly to the lowest value, setting everything equal to 0, and then dividing it by uh, multiplying it times 10, which happens to be the number of map parts as far as the different colors that are available being used, and dividing it by the difference between the highest and lowest. And this is to make sure that those it fits within the value as far as on the map. And I'll see if I can show you that real quick. If I go here, I'm using these colors, and there's 10 of them across here. And granted, I could have just filled up with all sorts of different textures and stuff like that. And because I want the values of the map to actually come into fall back into this, this is how I adjust it down. So you could adjust them a lot of different ways, and that's another area you can play with as far as improving. And you know, to make water take a greater area, you could sit there also use area things methods like erosion, you know, whether it's water, wind erosion, stuff like that, as far as on the maps and stuff, and apply those. I would suggest looking them up. They can add quite a bit of detail. It's also possible to go ahead and add cities, towns, everything on buildings, and use something like the um, terrain pathing system like A star to sit there and generate your roads and surfaces as far as going from town to town or building to building and stuff like that. So there's tons of stuff you can actually build as far as into the game, everything from resources into your map and so on. And these techniques can actually be used as far as for not just for 2D games like what we're doing right here, but you can also take this height map and place it into a 3D game, which is basically where I took it out of my previous some of my other work I did in the past. So that's just the first method. So let's go ahead and jump on to the next method, and go ahead and run it real quick. And as you see, we have a terrain here that's fairly randomly generated, but it's actually using a pseudo-random generator strictly in this one, so I can't show you what a pure random system would look like. I just haven't done it. And as far as in this code, now what this system works is it actually drops particles onto the map surface, all right, and determining the probability of a particle hitting the map and sticking, and also the probability of that particle rolling as far as to the next surface area down and so forth like that, right? Gives you different terrains. Okay, so in this case, what you seen me do is I just manipulated this to where it actually created more of a greater deviation as far as in the terrain area. That's the reason we're ending up with lakes, some mountains with a little bit of snow on it in between and stuff like that. And you can create all sorts of different terrains this way and actually end up with probably more lakes and waters or less lakes and waters and stuff and so on. So the way the system it works is if you had, let's say, let's just look at the code real quick and I'll show you. All right, so here we are as far as taking a random generator for what the pseudo random number out of 1,000, right? And if it happens to be greater than 990, then it sticks to the water area. All right. So only 10 out of 1,000 actually stick to the water area. And the reason we do this is so that the entire water area doesn't get used up. Otherwise, if we even just go down 50 right now, right, and you're talking about we're dropping 550,000 of these points, we get terrain that does like this. All right. So this has actually gone up into further texture areas. But we can go ahead and lower that down and reduce this to, let's say, 350,000, and it didn't build up as high and not all the water is used up, but there's still a few little mountain areas, but you have to kind of look for them. They're not as prevalent as all, and it has to do with the average of something dropping into an area or the chances of it dropping, and so you get different variations like this. Now you can sit there and reduce those variations by, if we take this out to, let's say, 800 here, right, and drop this down to maybe 200,000, we'll get something that looks entirely different, maybe very plain or, oops, what did I do here? I know I did something. Oh, 2 million, that's why. That would have took a while. Okay, so more brown as far as down there. And, sorry. So we get more of a grassland area as far as that with some, mud areas and stuff like that. And it's just how you want to, might want to manipulate it or not. And you could play around with this and see what all you can do on it. Now, the way it actually was working is, okay, we drop that piece down, and if it sticks to the water, great. But if it sticks, and then you get enough spaces where there's land, and you start getting stuff sticking to the land area, right? And it doesn't really test as far as to that purpose as far as to land. You can. I've built it in, all right, and it's using this random number, and it's greater than 20% chance here. So anything over 20, and it sits there and does it. But you can sit there and manipulate it, up and down, lower it, whatever. So you can make all sorts of changes there. But then it determines if there's like space for it to potentially roll one direction or the other. Right now I only have it rolling one spot, and then it's done. All right, but you could actually build that in towards an iteration where it looks to see once it's rolled that one spot if it could roll further down. All right, and you can sit there and actually take that out, and you may get better terrain, and you set it up as far as on that or how much it rolls down. You can sit there and have it rolling on the first hit on the first level, and let's say it drops with a 2 or a 3 or 4, right, and then rolls down a level, only goes to a 2, and then rolls down another level, goes to a 1, and you could actually, where it takes only a portion of the terrain down as it drops. And so you could manipulate this a lot of different ways, and I encourage you to play around with it, explore it, do it. Both these systems use very similar techniques as far as the rendering. The files are similar. You're going to find a generation that is being done in the chunk area. All right. Pseudo-random may not be exactly the same, or it might be. I don't know if I made them identical. I've been playing around with it quite a bit. Okay, and on render, you can sit there and change these heights. I mean, the scale area here to let's say 32 by 32. And the reason we have it so small is because we wanted to actually see the entire terrain. Later on, these aren't really going to be so much as far as in that regards. Uh, because I'm actually planning on taking each of these squares that are being generated as far as on this, because now this is what you're actually seeing is the textures that were being put into it instead of looking like a bitmap of the terrain on there. But each of these is actually going to be changed into a 256 by 256 area that the person's walking through. So they'll be able to go out to the larger map and sit there and look and see their area and see more of what's around it, but they won't see the whole thing unless they've got to that point where they can see more of it. So they'll have to explore it to identify it, and call it a fog of war option or whatever you want. But to see the entirety of the map we're generating, we reduce these down to a small value, and then we can sit there and post the entirety of the map up onto the screen this way, and we have this. And so anyway, like I said, I seriously encourage you to go ahead and play with these. I'm going to put both of these projects in a single file as far as on my system for you to actually download. You can download it from my website. Feel free to ask questions. I think my email address is on the site. If not, contact me through YouTube. And I hope you have fun with it. If you like it and you appreciate it, like the video and subscribe. I'll try and put more of this out here sooner. Anyway, thank you again for watching, and have a great day.